All right, so I'm Adam Rauch, VP of Product Strategy here at LabKey and co-founder of LabKey. And today I will be covering the topic of securing participant data with LabKey Server SDMS for regulatory compliance purposes. So what do I mean by regulatory compliance? Well, we talk about a lot of different regulations, guidelines in terms of compliance. Typically, or most often, HIPAA, FISMA, CFR Part 11 compliance, but we also have facilities for GDPR, GXP, etc. So lots of different regulations and guidelines, standards. We have about half an hour today, so I can't really go into a lot of detail about each and every one of these regulations. So suffice to say, we have built, designed, and developed LabKey from the start to handle compliance with all of these different regulations. And not just in theory, in practice, we have launched and operated and maintained compliant deployments on behalf of many different clients. So government entities like the FDA, nonprofit research organizations, commercial entities. We run compliant environments, compliant deployments for many of those types of clients. And we have helped other clients create and deploy compliant environments for LabKey Server as well. So, you know, as Stuart just talked about, we have a lot of expertise in deploying LabKey in a compliant environment. So, as the title kind of suggests, this presentation is going to focus in on one particular aspect, which is securing and protecting participant and patient data. Which is, you know, probably most relevant for HIPAA compliance. Again, HIPAA, you know, the privacy rule of HIPAA, I think is about 400 pages of regulations. So, you know, it's very difficult to kind of summarize that in a slide or two. But, you know, I think the best way to convey LabKey's role in HIPAA compliance is to talk about some of the key capabilities, some of the areas that we focus on in order to facilitate compliance. So I've listed three key areas here. You know, first of all, overall security, to identify and protect against security threats, whatever they may be. And then specifically to ensure confidentiality and integrity of PHI and other sensitive data. And then very importantly, to provide a means to actually audit the activities related to both security and PHI to ensure that, for instance, those within your organization and potentially those outside your organization who shouldn't be involved, that you are able to monitor all of the activities of those individuals related to sensitive information. Now, I know a lot of you are subject, or a lot of you, your research is subject to HIPAA. Some of you are not. You're maybe not a covered entity, or the research you're doing is not subject to HIPAA. That's okay. You know, we've developed these controls, these security controls, to facilitate HIPAA compliance, but they're also extremely useful for other purposes, for adhering to say your study governance practices or policies within your organization around whatever sensitive data you might work with. So that might be, you know, technically PHI in the HIPAA case, but it could be PII in the case of clinical trials, observational studies. Perhaps it's not participant related at all. Perhaps it's intellectual property that you want to protect. We have some of our clients are using these facilities on non-participant data, just intellectual property that's been developed within over the course of years, and only certain individuals are allowed to see that intellectual property. So the point is, these facilities are very general purpose and used in a variety of different ways. So I'm going to focus most of the discussion or most of the presentation on functionality within LabKey Server that facilitates compliance. So where does it start? This might seem obvious, or so obvious it's not even worth mentioning, but I think it's an important reminder that identifying users in a reliable, robust way is absolutely critical. It's a linchpin. If you can't identify your users reliably, then everything else after that kind of falls apart. So you need to have in place strong authentication that you can rely on. LabKey Server supports, as many of you know, multiple enterprise level authentication mechanisms, single sign-on mechanisms like SAML and CAS, enterprise LDAP and Active Directory services. We can authenticate against those. We have built-in database authentication that can be used if an enterprise solution is not available. And increasingly, as you've probably seen, two-factor authentication is being rolled out more and more pervasively, in response to a variety of security threats. So we support Duo two-factor authentication in addition to one of those other primary authentication methods. And importantly, I'll mention this as I go along, just as a reminder, but all of these login operations, both failed attempts as well as successful attempts, are logged for auditing purposes, so that an auditor can go back and see who logged in and who failed to log in, and monitoring of invalid logins can be accommodated. So once you identified your users, you know who they are, and you're confident of that, you need to provide authorization, appropriate authorization, for those users to be able to access the data that they're required to see. So this, of course, requires a robust, flexible access control framework, which LabKey provides. As you probably know, LabKey stores all data, partitions all data into folders, virtual folders. Administrators have full control over what that folder hierarchy looks like, what data goes into each partition, each folder. And then administrators provide explicit access to these data partitions by granting security roles within each folder. So typically, users are assigned to a security group or multiple security groups, and then those groups are assigned roles within a folder. So you can see on the right-hand side, just a simple screenshot. Many of you, I'm sure, have seen this and lived with this. This is a fairly straightforward way to assign security groups, to assign roles to individual security groups. So you're seeing here an administrator group, an editor group, an administrator role, an editor role, reader role, being assigned to various security groups within a particular folder. So those top three roles are fairly general purpose roles. Should be fairly obvious what kinds of permissions those roles are assigning to the users who are part of those groups. And then there are also within LabKey some more specialized roles, like you're seeing here, QC analyst, electronic signer. We'll be looking in a moment at PHI reader roles, which are involved in, which are very important to HIPAA compliance. So administrators assign roles to groups within a folder. And generally speaking, those role assignments apply to all data within a folder. So as an example, a reader will have read access to all of the data in a folder. That's the general rule. So the next 4 or 5 slides, we're actually going to explore some very important exceptions to that rule. But that's sort of the starting point is access control at the folder level, only assigning the roles to only the users who need access to data within that folder. Again, importantly, all security operations are logged for auditing purposes. And it's not sufficient just to provide an easy way to assign these roles. There needs to be, we feel at least, there needs to be a way to validate those assignments. And so LabKey provides detailed security reports and an impersonation feature that allows administrators to validate the permissions that they have assigned within the system. So I'll just mention along the way that feel free to type questions into the chat. I'll pause periodically and address those, and then we'll have time at the very end if there are further questions. So again, folder level or study level access control is kind of the foundation of the permissions model and access control. But there are ways to provide finer grained access control. So one key way is within a study to make use of dataset security or dataset level access control. This capability, it's specific to studies and datasets, and it allows administrators to assign roles to specific security groups on a per dataset basis. So why would I want to do this? Why is this interesting? Well, one example, let's say I have a clinical trial and I have a cohort data set which defines the cohorts for each and every participant within that study. That data set, maybe I want cohort blinding for most of the users who access this data. In other words, I don't want that cohort data set to be seen by anybody but the study administrators. And so I can accomplish that with dataset security by specifying that the study administrator's security group is granted read permissions to the cohort data set, and perhaps no other groups are allowed to see that. And if I set that up, then most users who go to the study will simply not see that data set. But the study administrators, if I'm a part of the study administrators group, I will be able to see the cohort data set in its entirety. Likewise, I might have a phenotypic data set that is viewable by all, but can be edited only by the security group members, users in the clinician's security group. That can be facilitated by dataset security as well. And then finally, let's say I have I'll call it a sensitive demographics data set with, perhaps some PII as a part of it. And perhaps that data set should only be read and queried by those in the trusted analyst security group. So this facility can be explored and used by simply going to manage study, manage security, and then choosing one of the custom security options within the manage page. So dataset level security secures an entire data set. Either you see the data set or you don't. Either you're able to edit the data set or you're not. Participant level access control provides even finer grained access control within data sets. So in this case, administrators have the option of restricting each and every user's dataset access to only a specific set of rows associated with the participants that that user is allowed to see. So again, useful to talk about an example. Let's take a multi-site study. Let's say, in fact, I've got a 50-site study. It's a global study where 50 sites are contributing data to a single study. Each site recruits and manages a certain set of specific participants, and that site is responsible for those participants and submitting those participants' data. So let's further say that we've got a sensitive demographics data set that is managed by each site, and we've got a phenotype data set that's managed by each site. So the sensitive demographics data set, in that case, perhaps I want to set things up so that only the users from each site are able to view the rows for the participants that have been recruited and managed by that site. So in other words, users who belong to site A can see only the participant information for participants who come from site A. And then likewise, this phenotype data set, only users from a site are able to edit the participants from that site, edit the rows associated with participants from that site. So this allows for, within this multi-site study, allows each site to kind of control and view the sensitive data associated with participants from their site. So for maximum flexibility, this set of allowed participants for each user is determined by a custom query that's written by an administrator and then associated with an individual data set. So I can provide different queries depending on and associated with each of those with each data set. And then, as you can see on the right-hand side, just as a simple example here, if I go to this study and the specified query associated with the data set returns, say, these 6 particular participant IDs, those are the only ones I'm allowed to see. This data set that would normally have hundreds of rows, I only see 6 rows because those are the only participants that I'm allowed to see, and none of the other rows will appear for me. So the query that gets written can involve any LabKey table or query. So you've got kind of full flexibility as to how you, as an administrator, how you determine which participants each user is able to view. So again, an example doesn't have to necessarily work this way, but an example, let's say I have security groups associated with each site. So that identifies all the users who are associated with site A, all the users associated with site B, site C, etc. And further, let's say I've configured participant groups to contain the participants from each site. If I then write a simple LabKey query to join the current users' security groups with the participant group membership table and join them by name, so by convention I use the same names in both places, join by name, and now my query will show all of the participants who belong to the site where I'm currently a member, or perhaps multiple sites if I happen to be a member of multiple sites for some reason. But that's just an example. The query again could use ad hoc tables or lists. It could query any table that's available within the system in order to answer the question of which participants am I allowed to see. I'll just mention this participant level access control is an enterprise edition feature. So those who subscribe to the enterprise level can make use of this. Okay, so for HIPAA compliance, protected data handling and logging is absolutely critical. This is kind of in some ways, the key feature built into LabKey for handling protected information. So if you remember on the previous slide, we talked about restricting by rows. In this case, we are restricting data access by columns. So specifically, administrators have the option to annotate columns within data sets, lists, sample types, data classes, etc. Administrators can annotate columns with a PHI level. There are 4 different levels. These names correspond to the HIPAA terms, although you have full flexibility in determining what each of these levels really represents within your data. So in some cases, as we talked about before, it might not technically be PHI, it might be PII, or it might be intellectual property or some other sensitive data. But you can essentially tag columns at these different levels. And then any column that is annotated as PHI, so limited, full, or restricted, no one can read that data unless they're explicitly granted one of these PHI reader roles. So again, we have multiple levels, limited PHI reader, full PHI reader, restricted PHI reader. Even administrators don't automatically get the ability to read PHI. They must be explicitly, they and everybody else must be explicitly assigned, explicitly granted a PHI reader role. So what you're seeing on the right-hand side is a data set where gender, cohort, and treatment group have been annotated as PHI columns. And the current user has not been granted any PHI reader access, haven't been granted any of those roles. And therefore, that user sees blank columns. When LabKey renders it, it's actually not in black. It's just an empty column shows up. Or administrators also have the option of hiding those columns entirely, if that's desired. So in this case, I just showed it in black just to kind of emphasize those columns kind of disappear. And you might be able to see that we also there's sort of hash marks in the header on these columns, and the hover over will indicate you're not seeing this because you don't have the appropriate level of PHI reading. So importantly, these columns are not available no matter how the user attempts to access the data. So we're seeing a grid example here, but if you export the data, if you use an API, if you use a report, any query that's on top of this, no matter how you attempt to access this data, those columns will always be empty. So in addition to preventing access for those who are not allowed to see this data, we also, very importantly, have the option to log any access to PHI, any access to this data. So you're allowed to see the data. You have been assigned one of these roles, so you technically are allowed to see it, but it's still important that we log each and every access so that auditors, again, can go through and see who has been looking at data, what data have they looked at, which participant IDs, and try to answer the questions of why was that access required. So a number of logging options. You can log nothing if you want, but the interesting options are to log every query involving PHI columns. So those log entries include the user who's taking this action, who's viewing the data, timestamp, the participant IDs that were viewed, and the columns that were accessed with that view. There's also the more verbose option of simply logging every single query that takes place. So that, that provides much more detail, but then needs to be mined for useful information. So likewise, similar to the participant level restrictions, all of the compliance controls and protected data handling like this are enterprise edition features. So there are a couple of other options for what I'm calling here judicious data sharing. So these come up in a variety of different scenarios. There's not really one. Well, I can give a few examples, but there are a lot of different scenarios under which folder export and publish and linked schemas come in handy. So folder export and publish study, the folder export import mechanism is a very powerful way to share data. You might share data with another LabKey server. You might share data with another project on LabKey. Publish study is used typically to create a snapshot of a study, subset that study in a variety of different ways based on visits or participants or timeframes or other interesting sort of slicing and dicing. That mechanism, folder export and publish study, provides some participant level data scrubbing options. So you can, in that process, tell the export process to exclude PHI columns at a specific level. You can shift participant dates within the study. So each participant's dates get shifted by the same offset, but that offset differs for each participant, if that makes sense. So the reason being there, if you're, the exact date is going to shift, but in theory, all of the graphing and analysis that you might do remains the same because the differential between each date remains constant. You can also choose to export alternative participant IDs. So LabKey, instead of sharing all of your internal IDs, we will map to an alternative set of IDs, and we'll generate those randomly if you want us to. And we also have the option to mask clinic names, since a clinic might, could arguably be an identifier in a sense. If I know a clinic name, I might know a neighborhood and be able to narrow down who a participant might be. So all of these facilities, one example of the use of this was, say, publish study. We have the, for instance, the Immune Tolerance Network runs a large number of clinical trials, and they make the study data available to the public. So they literally on LabKey will publish studies and make those studies available for analysis and viewing and review by the general public. In that process, they needed a way to make sure they scrubbed their study data, their participant data, of identifiers, of dates that might be considered identifiers, et cetera. So this facility allows for that. It's also useful even in cases where the data is not going to public. You might be sharing data with a collaborator, and there's certain data that you need to protect or scrub in that process. So another mechanism is what we call linked schemas and tables. This provides for kind of restricted data sharing in a different way. So you can sort of think of this like a cross-folder query, where you have the ability to restrict the tables and the columns that appear, and you can apply any number of filters to the source data. So this is a simple example here. This little XML snippet is basically saying, I want to share a table of information, but I want to apply a filter to it before it's available to any of those users. And in this case, the in-use column must be true. So that means all of the rows where in use is something other than true, most likely false, will not appear in this linked table. So again, this is, a scenario here might be you're running a study, you have a bunch of data in that study, you want to share some of that data with a collaborator, but in that process, you want to leave out certain data, certain rows, certain columns, certain tables that are either not of interest or that need to be protected because they're sensitive. All right, so I've focused pretty squarely on protecting participant and patient data, protecting certain elements, and how do we keep that data in the right hands and out of the wrong hands. But there are a variety of other compliance controls that are kind of important in the big picture when you're talking about HIPAA, FISMA, Part 11, et cetera. And so I just wanted to kind of touch on those other capabilities just so that folks are aware of them. So we have customizable terms of use, where we require every user to accept terms of use before each session. So basically, at login, they need to accept terms of use. We have a variety of user account management capabilities. So you can, and all of these are configurable by administrators in terms of, so for instance, inactivity period or disabling user accounts after a fixed time period. These things are all configurable in terms of turning them on and then the period of time that that is configured. There are facilities for blurring the screen. So if someone walks away from their computer and their session times out, we will blur the screen so that to reduce the chance of PHI being left on a screen for a long period of time. And then once they've been logged out, the user has to log in again in order to see any of that data to, again, ensure that that user is actually allowed to see that PHI. We also have a project locking and review workflow, which is useful for validating permissions on a periodic basis, electronic signing of data, et cetera. So variety of different compliance-related controls you can take advantage of in your deployments. All right, so some of the key takeaways in terms of features and functionality. I think it's fairly obvious that LabKey Server provides many options for securing participant and patient data. It's a lot of different options, but we provide resources to help you understand those different options and evaluate them and determine which one is going to be most appropriate, which one or ones are going to be most appropriate for your purposes. So I always like to point to our documentation. We spend a lot of time explaining both the nuts and bolts of how to use these features, but also the scenarios and the caveats around all the different features. So I will point you at the documentation for all of these features. and remind you that, assuming, every client with LabKey has an account manager, and that account manager knows these features. They're experts in the use of these features and can help you understand them and assess the different features. And then I'll just encourage you, don't be scared to actually try out these features. Particularly on your staging environment or test environment, turn them on, try them out, use the PHI capabilities, use the the different compliance controls that I've mentioned, try them out and see, get a sense for how they work, and then circle back with your account manager if you have questions, etc. So that kind of covers the functionality that I wanted to talk about today. Because the last thing I will just mention is operational considerations. So you already had a presentation by Stuart, who covered most of this already. This is kind of my one-slide version of his presentation, kind of zeroing in on the sort of the compliance, most important elements from a compliance standpoint. As Stuart talked about, you can do this yourself. You can deploy LabKey Server in a compliant manner. I think, importantly, it's not sufficient just to use all of these features. You have to also deploy LabKey Server in a compliant manner. So again, you can do this yourself, or you can take advantage of the compliant cloud that LabKey offers. Either way, there are a large number of security aspects that must be managed and addressed. Stuart talked about all these, but make sure that you address these or talk to us, and we can help you out if you need them. All right, so happy to take some questions if there are any. Okay, so question, do the access controls you described apply to external data like EDC data? So short answer is yes, meaning to the extent that LabKey is configured to integrate with electronic data capture systems like RedCap or Metadata Rave or external data sources or other facilities that that bring data into LabKey. When those data are imported into LabKey, they will likely go into data sets or lists that can then be secured using PHI annotations, so that all of that data continues to be protected in the same way as kind of native data sets that are imported from, say, TSV or Excel files. And so how do access controls apply to API usage? So it's no different than viewing by, viewing grids or exporting or anything else. All of the rules in terms of both permissions, so access control in terms of folder level access, participant level access, data set level access. All of those rules apply whether you're looking at a grid of data, you're exporting, or you're using APIs. Likewise, same thing with PHI level or PHI annotations and PHI roles. Those rules are respected regardless of your mode of access to the data. So in other words, APIs, it all applies to APIs as well. I think I mentioned this on the slide, because HIPAA is very strict. Well, many of the compliance regulations are very strict about accepting ensuring that terms of use are accepted before accessing data. We have a facility called a session key, which can be used with API access. Session key basically, it essentially asserts or links a user's acceptance of terms of use with API access. So basically the process is I go to LabKey, I accept the terms of use. Based on that, I can get a session key that I can then use for API access. And that kind of ensures that the user using that API has accepted the terms of use for the data that's being accessed. So this question about compliant environment and is there a requirement that the compliance module is used? I guess in most cases, where LabKey is deploying a compliant deployment, we will use that compliance module since it kind of embodies the various controls that help ensure compliance with those regulations. It's not strictly speaking required. The HIPAA and other regulations allow for addressing the hundreds of controls that are a part of those regulations in using manual techniques. So strictly speaking, you don't need the compliance module, but the reason we built it is to automate some of the, in particular, some of the more tedious controls and make that just an automatic process. So